Hello people, this is the first problem of the sample test that I have posted for the midterm that's coming up. Now, there is a tutorial like that, there is a video clip like that, very similar to it in YouTube, but uh, the, the geometry is even more complicated. The geometry in that problem is that these arms are both actually curved, okay? So I'm going to do a simpler problem. Now, the parts in this problem were provided to the students, so they had to go to the appropriate location in the Y drive and download it. And I suggested that you make it yourself because you don't have access to those parts as a sample test. However, I will make these parts, except that they may not exactly look the same, particularly at this bottom end. So that's really irrelevant. Okay, so we may have to come back to this later on and look at it. All right, here's the product. Immediately I save it. File, save management, save as, desktop, new folder. I'll call it problem 1, sample test. Okay, and I'm going to ignore completely the geometry and the dimensions of the problem. Not the geometry, dimensions of the problem. Okay, so insert a new part, and I'm going to call it the wall. Right click, properties, wall, and wall. Okay, let's make it. So double click on the wall, on a convenient plane, on this vertical plane, I will sketch. Okay, I'll sketch a rectangle, that. And down here I'm going to make a little circle, and we're going to have the arm, one of the arms sticking to this circle. So why don't we pad this? So this is the wall. Let me actually make this thing 1 inch, a little bit fatter. And on that face I will sketch. Actually, on the side face, on this side face, I will sketch. I changed my mind. Okay, on that face, I will sketch. All right, some geometry like this. Because I want to make a pocket and remove material out of that wall. So I'm going to pocket. How about making it 0.5 so that it removes half an inch. The dimensions are not important. Okay, so immediately we're going to save everything. And my way of saving, and click on the floppy. Then we're going to insert the lower bar and then the upper bar. Now when I say lower bar, I think here it's got big arm and small arm. How about that? Yeah, big arm and small arm. And I noticed that in my drawing, actually there is a pin here in the wall, but I made it a hole. That's one. Okay, so insert a new part in there. Say no. I'm going to call it the big arm. Properties, big arm. And down here, also big arm. Okay. So let's make it on a convenient plane. On that vertical plane, I will sketch. Why don't I project this guy, project this fellow? So, because I'm going to make a pin in my big arm, although it's unnecessary, but I want to make it look good. Okay, so Then we're going to do the rest of this, so perhaps something like that. And I understand that the bottom of this arm does not look like what I have in the drawing, but that's okay. Alright, so exit, a multipad, because I want to make a pin. So this one, let me make it 0.5, and this one I'm going to make it 1, because, oops, because you can see that I made the pin in here instead of the wall, which is fine. Then on this face, I'm gonna sketch. Is that the face? Yeah, right here. That face that I drew there. I'm gonna sketch something like this. I want to make a pathway so that the small arm can slide. So let me see now. Just although it's not necessary, but I would. I mean, this can be made symmetrically, but that's okay. I'm going to leave it the way it is. Or maybe we should make it this one and that one. I'm going to make it 0.2, 0.2, and the same thing down here. Dimension between this and that. This is only for cosmetic reasons. 0.2. Okay, very good. Exit, and then we make a pocket. Let's see, pocket. I don't know. So let's drag this thing until we're happy. Or put a number. Oops, not this. There. Actually, this is the second limit. Let me cancel this. Try it again. Pocket, and give it actually a number. How about maybe 3? See how it looks like. Yeah, a little bit more. Maybe 5. Oh, that's too much. Whoa. Make it 4. Alright, very good. Okay, so exit, save everything. Then we're going to insert the small arm. Insert how about new arm, new part, and we're going to call it new arm, small arm. Sorry, small arm and small arm. Okay, and we're going to make it. So on a convenient plane, on this plane, we will sketch. Okay. All right. Why don't I actually project that entire face? This entire face. There we are. There. And I'm going to pad it. Okay, where's the pad here? Exit and pad it. Okay. Let me see my drawing here. At this end, I have a circular end, which really doesn't matter. I'll leave it as a flat end at this side. It does not change the nature of the problem. Now, why don't I make this thing 6? See how it looks like? Yeah. Okay. Very good. Okay. And on that face, I will draw a circle. Right there. exit and pocket. All right. Okay, so and then I'm going to make the wheel. So save everything. Okay. So on a insert a new part. Okay. I'm going to call this thing the wheel. Properties. Wheel and wheel. And let's make it. So on a convenient plane, how about on this plane? I will sketch. Why don't I project that circle? This is to create a shaft for the wheel. There we are. And then we can right, we can pad that. Let me see for a second. Yep, we can pad it. Pad that sketch. Where is that sketch? The one that we just projected. I think it's this one. And I'm going to do it all the way to, oops, all the way to, okay, all the way to that plane. Okay, so actually you can see if I, so this thing was projected all the way to that plane, and I'm going to make the wheel, and the wheel is going to be half an inch into that piece. So let me see for a second. Let me hide this. So on that face, I will sketch. A circle there. We can make it concentric in a minute. Okay, so this, control that. We're going to make it concentric. Okay, and we make a little indentation here so that we can see actually that the wheel is rolling later on. Exit, pad it by in the other direction, reverse the direction by 0.5. We may have to change this thing. I don't know how it's going to look like. So let me bring that wall. So you see, where is the wall here? It's in hiding. Let's bring the wall in the front. Yeah. Okay. For now, we leave it the way it is, and then we proceed. We may have to change some of these sizes. Now, you don't have those problems because those parts were given to you, or will be given to you if there is a problem with that. Okay. So first thing I'm going to do is I anchor the base or the wall, and then I'm going to move these things apart so that you can see what's going on. So translate in X direction. There's the wheel. I'm going to move the wheel here. Okay, let's put actually this one in there. So coincidence between this face. Okay, how about this face and that face? And coincidence between this axis and that axis. And update. Oops, it's the other way around. So let's undo this. Where are my constraints here? The constraints are right there, and this plane is not what I want. I want, oh yeah, double click on this and flip the arrows and update. There, that's a lot better. Okay, the only thing is that actually I wanted this guy to be on the other side, so I don't like the way it is, so I'm going to flip the arrows again, update, okay, and yeah, I don't like this thing, the way this thing works, so let me delete this constraint, move this thing out, move this part out, like that. Okay, maybe the easiest way is to actually see this pin is on the wrong side. So why don't I actually mirror? Let me go to this part, okay, and I'm going to use mirror. Where's the mirror here? Transformation, mirror. Okay, I guess this is not the a good way of doing it. Okay, so let's do this. You go on that side, on this side, and sketch on it. Hide and show. I'm going to sketch on it this circle. Projection of that circle. Exit and pad it. Okay, so 0.5. Alright, good. So I have a pin on this side and on that side, doesn't matter. Where is the wall? The wall is in hiding. Let's bring it in the front. Okay, let's do it now. So back to the assembly design. We already have a axis to axis coincidence. You can see that coincidence between this plane and that plane. Where is it? This update. Very good. Okay. I have this little thing here which is not bothering me. So now let's put this thing in that. This guy is the two arms together. They make a prismatic joint. So coincidence between this line and, just to make it look exactly the way it's supposed to be, and that line, and coincidence between this plane and that plane. Update. There we are. Okay, I can actually move this thing a little bit, so translate it in this direction. So translate in an arbitrary direction, and you pick the direction right here and right there. You can see that. All right, very good. Okay, now let's insert the wheel in there. So coincidence between the axis of this. Where's the wheel? Oh, the wheel is over here. And the axis of that, and coincidence between this plane and that plane. And update. I'm hoping that I was hoping, and that is the case, hoping that this edge of the wheel actually lies in that plane. That's good. So let's actually move things. Let me move things apart a little bit. So translate in this direction. Make sure that the constraints are respected. See that? I want to put it way up there. I want to put this guy way up there. Okay. Now I just noticed that this is not long enough. You have two choices. We can make this thing longer or that longer. So I haven't decided yet But let me move it further back. Okay, and I want to bring this thing and put it on that face. We're going to have to change the size of these things. Okay. My mouse is not working. The button is not working here. Okay, I'm going to do a contact between the face of this wheel and the face of that face. And if internal doesn't work, bring it to external. So update. Okay, so we want the other one. Not internal, we want it to be external. Update. Okay, that's a lot better. Now the only thing is that notice that this is not long enough. We have two choices. We can leave it the way it is, or we can change the size of these things. I don't know. Let's find out. Let's try the size of this. Which part is this? This is the big arm, supposedly. Big arm. And we had a pad here. That's this pad. That's big arm. Oh, big arm. That's what I want. I want to go in the big arm. And there's a pad here. That's a small arm. I don't want to go there. A wall. Big arm. We go to the sketch here. Let's make this thing longer. So right now the dimension of this thing is 4. Let me make it 6. Okay, let me make it 7. Yeah, that looks good. Exit. Okay. Yeah. Okay, very good. So I think I have all the constraints that I want except the roll curve joint that is this along that. Now I don't know whether when it rolls it's going to go in this direction or the other one. We may have to adjust that later on. Okay. I'm going to save everything. Okay, so let's go to digital markup. Game View kinematics. Get the magic wand out. New mechanism. Auto create. I suspect that we're going to have one revolute here, another revolute there, and a prismatic there. And the one that's unresolved is because of that contact that we have to create manually. So 2 revolutes and 1 prismatic. Yeah, very good. Okay, so now we're going to do the, let me zoom out. Now we're going to do the roll curve joints. First of all, I'm going to save. Where is the roll curve? There is the roll curve. This on that edge. Okay, degree of freedom is 1, and we can make this roll curve length driven. Oh, actually the problem that we have, remember, we are told that this revolute, the revolute here, the revolute here is turning at 30 RPM. So that's between this small arm and the wheel. Double click, you make it angle driven. Let's put it 0 and 360, and actually it will go to the left, as you can see. Mechanism can be simulated, and you can check that. It's going to go to the left. Very, very good. Okay, obviously if it goes for 0 to 60 full turn, this will not go all the way. That's okay. We have to put some physics into the problem. All right, here comes the physics of the problem. So okay, so let's go ahead and where is the f of x? F of x right there. Mechanism, angle equal to other formula. 30 RPM is 180 degrees per second. 180 degrees in 1 second times time. The time is here. Double click on it and say OK. And we say OK. Now, I just want to point out to you that you were asked, we're going to run this thing for maybe two or 4 seconds. 2 seconds will not take you all the way to the, so I'll make it 4 seconds. But I want to point out to you that there is information that you're asked to generate here. These you should be able to do. I'm not going to do in this video tutorial, okay? You go and figure it out. We have done numerous examples, homework, and problems that it tells you how to plot specific things versus time, how to plot customized graphs, so one thing versus one thing else, magnitude of the linear velocity, for example, versus magnitude of the linear acceleration. Okay, now when you create a sensor, it's not going to say magnitude, it's going to say x component of x linear velocity, y linear velocity, z linear velocity, or linear velocity. The one that doesn't have x, y, z is the linear velocity. Okay, or the one that doesn't have x or y or z is the magnitude of the linear acceleration. I'm not going to dwell on those things here. You figure it out based on watching the other things that we have done in the last 5 weeks. Okay, so all I want to do is here to do a simulation with laws right there for a period of 4 seconds. 2 seconds took you almost halfway, so I'll do 4 seconds. Okay, and then plot it. Simulate it. There. 2 seconds is almost there. 4 seconds always takes you to the left. Please expect for more complicated rules than what we have here based on a single formula. It's perfectly legitimate for me to ask you to use for example, velocity that changes in different intervals of time. Okay, we have done problems where the position was given to you in a certain interval, which means velocity was given to you in a certain interval, changes in a different interval, etc. That's the one that I provide you with the graph. We have to write some if statements in the knowledge word toolbar, write a few lines of code. Now, I said in class that for the test, if you cannot get those things to work, if you cannot write a simple C code to do what I want, then in your test paper, tell me what is your rule. What rule are you following? And based on that rule, because maybe you don't know how to write program, okay? But at least you know what we did now. So state your rule on your paper, and then based on that, generate the graph. So at least you don't lose, 15, 20, 15 marks. At least you get some part marks for some of the graphs that you have generated. And it's important that you generate the graph in the units that we want, and you generate only graphs that we want. Otherwise, if you generate a lot of graphs unrelated to what we are asking for, or even related but not the one that we are asking for, we're going to take off marks. Okay? Good luck, guys.